Yeah. So this is a pretty challenging problem. So like, yeah, let's take a look at it. So in this question, we're given a square with area 4, and it's inscribed in a square of area 5. And we're given one vertex of the smaller square on each side of the larger square. And a vertex of the smaller square divides a side of the larger square into two segments, one of length A and the other of length B. We want to find what is the value of A times B. Okay, so there actually turns out to be two ways to do this question, but I'll just show the more like algebraic solution, I guess. So basically, what we would do is notice that like by symmetry, right? Like this triangle, like all of these red triangles, right? By like just by pure symmetry, like all these red triangles are going to be congruent, meaning like they're all like essentially the exact same triangle, except you kind of rotate them. They're in different configurations, but overall, they're still going to be the same triangle. Which means that like if this has length A, that means, and actually let's say this, if this has length B, then this has to have length B, right? Just by the symmetry of the triangles. They're all congruent triangles. And this is a right angle, right? So we can apply the Pythagorean theorem. We can find that this red length is going to be equal to the square root of A squared plus B squared by the Pythagorean theorem. So we're given that the area of this small square inside is 4. Like that's what they told us. And that we know the side length is the square root of A squared plus B squared. So the area of the square is just gonna, you take this side length and you square it. So you take square root of A squared plus B squared and you square it. You get A squared plus B squared. And this has to equal the area of the entire square, which is 4. And you can do the same logic for the big square. Like this square like colored in green, like this big square, like the entire thing has area 5. And it has side length of A plus B, right? A and B, A plus B. So the area of like the big square would just be the side length squared. So you do A plus B squared. And this has to equal 5, right? We're given the area is 5. So we can expand this part out. Is A squared plus 2AB plus B squared is 5. And notice that like this A squared B squared conveniently matches this A squared plus this B squared. So we can replace this A squared plus B squared with the 4 instead. So we're given 4 plus 2AB is 5. So conveniently, notice we don't have to solve for A and B individually. The question wants us to find A times B. And that's pretty convenient because we have A times B right there. We can subtract 4 on both sides and we get 2AB is 1 and divide by 2 on both sides. So you get AB is equal to 1/2. And that would correspond to choice C. Yeah, choice C. And that would be our answer. So 1/2. Show the second way, but I'll just briefly explain what it would be. Like the general idea. The general idea is to notice A times B. If you notice that A times B divided by 2 would be like the area of one of these like congruent triangles. So to find like the area of one of these like small little triangles, you could just take the area of the big square, which is 5, subtract the area of the small square, which is 4. So the sum of the areas of the 4 like congruent triangles must be 1. So each triangle must have area 1/4. Which tells us that AB must equal 1/2, which might be a faster way to solve this problem. But you could also do it this algebraic way. It's definitely also a valid solution. And yeah,